A visitor from another star system just passed through our solar system. And what scientists are seeing doesn't match anything we've ever encountered before. Meet Comet 3I Atlas, officially designated C2025N1. On July 1st, 2025, a robotic telescope in Chile detected something that shouldn't exist. An object moving through our solar system at 58 kilometers per second, faster than any comet we've ever tracked. When astronomers calculated its trajectory, they realized this visitor had been traveling through the void of interstellar space for potentially up to 11 billion years. That's older than Earth itself. They named it 3I Atlas, and what scientists are discovering about it is rewriting everything we thought we knew about interstellar objects. Some are even asking, could this be our first detection of alien technology passing through our cosmic neighborhood? Stay until the end. I'll show you the one chemical signature that even skeptical scientists are questioning. Before we dive into 3I Atlas specifically, you need to understand just how rare and significant interstellar objects are. For all of human history, every comet, asteroid, and space rock we've ever observed originated from our own solar system. They orbit our sun in predictable patterns. But interstellar objects are different. They come from other star systems, hundreds or even thousands of light years away. The first confirmed interstellar visitor, Oumuamua, wasn't detected until October 2017. That's only 8 years ago. Before that, we had theories, but zero confirmed detections. Then, in 2019, amateur astronomer Gennady Borisov spotted the second one, 2I Borisov, using just a 0.65-meter telescope he built himself. And now, 3I Atlas makes three. Three confirmed visitors from beyond our solar system in human history. That's it. But here's the thing. Scientists think interstellar objects might actually be passing through all the time. We just couldn't see them until now. 3I Atlas was discovered by the Asteroid Terrestrial Impact Last Alert System, ATLAS for short, a network of robotic telescopes that scans the entire night sky every 24 hours looking for anything that moves. It's essentially a cosmic security camera system. On July 1st, 2025, the ATLAS facility in Chile flagged an unusual object. At first, astronomers thought it might be a long-period comet from the outer Oort cloud. But when they calculated its orbital eccentricity, they got a number that changed everything: 6.1. Now, if you're not an orbital mechanics expert, let me explain why that's shocking. An eccentricity of 0 means a perfect circle. 1 means a parabola, the boundary between staying in orbit and escaping. Anything above 1 means a hyperbolic trajectory. The object is moving too fast to ever be captured by the sun's gravity. Oumuamua had an eccentricity of 1.2. Borisov was 3.4. But 3I Atlas? 6.1. The highest ever recorded for any object in our solar system. This isn't just passing through. This is screaming through at speeds that prove beyond doubt it came from interstellar space. But the eccentricity was just the beginning. When they analyzed its composition, they found something that shouldn't be possible. Once 3I Atlas was confirmed as interstellar, observatories around the world turned their instruments toward it. What they found was bizarre. First, the age estimate, potentially up to 11 billion years old. To put that in perspective, our entire solar system is only 4.5 billion years old. This object has been wandering through the galaxy since before Earth existed, possibly since before our sun even formed. But here's where it gets really strange. When spectroscopic analysis revealed its chemical composition, scientists found something unprecedented. 3I Atlas has an extraordinarily high carbon dioxide to water ratio, among the highest ever observed in any comet. That's vastly different from typical comets, which are water-rich with relatively little CO2. 3I Atlas is the inverse, and it gets weirder. Spectrographic readings detected nickel vapor and cyanide in its coma, the cloud of gas surrounding it. Nickel vapor has only been detected in a handful of comets ever, and the combination with cyanide in these proportions is completely novel. This chemical signature tells us something profound. 3I Atlas formed in a stellar environment completely unlike our own. But which one? Tracing 3I Atlas back to its origin is like cosmic detective work. Based on its trajectory and velocity, astronomers believe it came from what's called the thick disk of our galaxy, a region of older stars that formed billions of years ago. The extreme CO2 to water ratio suggests it formed near what astronomers call the CO2 ice line, a specific distance from a star where carbon dioxide can freeze, but water remains gaseous. This zone exists in the outer regions of planetary systems, beyond where Earth-like planets form. The carbon depletion and nitrogen enrichment point to a star system with different elemental abundances than our Sun, possibly a red dwarf or an older metal-poor star. Here's the mind-bending part. 3I Atlas has been traveling for so long that the star system it came from might not even exist anymore. Stars live and die. The parent star could have gone supernova billions of years ago, and 3I Atlas is just out there, wandering. A cosmic orphan from a dead stellar family. But if 3I Atlas has been traveling for billions of years, how did it survive? And what does that mean for what else might be out there? Let's compare all three confirmed interstellar visitors, because their differences are as revealing as their similarities. Oumuamua, discovered in 2017, was the game changer. It was small, maybe 100 to 400 meters long, and shaped like a cigar or pancake, depending on who you ask. It showed no comet-like activity, no tail, no coma, just a dark, tumbling rock moving at 26.3 kilometers per second. Its lack of outgassing baffled scientists and led Harvard's Avi Loeb to propose it might be artificial, perhaps a light sail from an alien civilization. Then came 2I Borisov in 2019. This one looked like a comet, a typical, well-behaved comet. It had a bright coma, a tail, and its composition matched comets from our own solar system almost perfectly. It was 0.5 to 1 kilometer across, traveling at 32.3 kilometers per second. Borisov reassured scientists that interstellar objects could be normal, natural comets. But now, 3I Atlas throws everything into question again. It's faster than both, 58 kilometers per second. It's potentially much larger. Estimates range from 1 to several kilometers across. And unlike Borisov's familiar chemistry, 3I Atlas has that bizarre, carbon-depleted, nitrogen-rich, CO2-dominant composition we discussed. Here's what makes this comparison so fascinating. We now have 3 data points, and they're wildly different from each other. Oumuamua was rocky and inert. Borisov was icy and active, just like our comets. 3I Atlas is active, but chemically alien. So which one represents the typical interstellar object? The answer is, we have no idea. With a sample size of 3, we can't determine what's normal and what's exceptional. It's like meeting 3 humans and trying to describe all of humanity. You'd get wildly different conclusions depending on which 3 you met. This diversity raises a critical question. If just 3 objects are this different, what else is out there that we haven't detected yet? And could some of those objects be intentionally designed? No discussion of interstellar objects would be complete without addressing Harvard astronomer Avi Loeb. After Oumuamua's discovery, Loeb co-authored a controversial paper suggesting it could be a light sail, a thin, artificial structure propelled by starlight, possibly sent by an extraterrestrial civilization. The scientific community largely dismissed this, but Loeb didn't back down. He founded the Galileo Project, dedicated to searching for evidence of extraterrestrial technology. And now, with 3-Eye Atlas, he's asking similar questions. In recent interviews, Loeb has pointed out that we've only detected 3 interstellar objects ever, a sample size far too small to determine what's normal versus anomalous. He argues that dismissing the possibility of artificial objects is premature. His position is this: if advanced civilizations exist and have been around for millions or billions of years, they've likely sent probes throughout the galaxy. Statistically, some should pass through our solar system. The question isn't whether alien probes exist. It's whether we're willing to look for them seriously. With 3-Eye Atlas's unusual chemistry and extreme velocity, Loeb suggests we should at least consider the possibility that some percentage of interstellar visitors might not be natural. Whether you agree with Loeb or not, he raises a critical point. How would we even recognize alien technology if we saw it? Of course, the vast majority of astronomers disagree with Loeb's alien hypothesis. Their counter-arguments are compelling. First, the sample size problem cuts both ways. We've only detected 3 interstellar objects, which means we have almost no baseline for what normal interstellar chemistry looks like. 3-Eye Atlas's unusual composition might simply reflect conditions in a different stellar nursery, not evidence of artificiality. Second, the extreme CO2 to water ratio and carbon depletion can be explained by natural processes. If 3-Eye Atlas formed in the outer regions of a planetary system around a carbon-poor star, these ratios make perfect sense. The nickel vapor? Rare, yes, but detected in other natural comets. The cyanide? A common organic compound in space. Third, the high velocity isn't suspicious. It's expected. Objects ejected from their home systems billions of years ago would naturally accelerate through gravitational interactions with other stars over time. Some scientists argue that invoking alien technology for every unexplained phenomenon is a form of God of the gaps reasoning, filling unknowns with extraordinary claims rather than accepting we simply need more data. They point out that Borisov looked completely normal, suggesting interstellar objects are just objects. Natural debris from planetary formation, scattered across the galaxy. On this channel, we like to keep an open mind. So who's right? The answer might depend on what we find next, and whether we're even looking properly. Here's the uncomfortable truth. We're almost certainly missing most interstellar objects that pass through our solar system. Atlas and similar surveys can only detect objects that are bright enough and close enough. Small, dark objects, exactly what an artificial probe might be, would slip past unnoticed. Some estimates suggest that for every interstellar object we detect, hundreds or thousands go unseen. Even worse, by the time we detect them, they're usually already leaving. Oumuamua was discovered after it had already passed its closest approach to the sun and was heading back out. We got one chance to observe it, and we missed most of that window. The same is true for 3-Eye Atlas. It's moving so fast that a detailed study is extremely limited. What we really need is early warning. The Vera C. Rubin Observatory, set to begin operations, will scan the entire visible sky every few nights. It's expected to detect dozens of interstellar objects per year, maybe more. The Nancy Grace Roman Space Telescope will add infrared capabilities, letting us see darker, cooler objects. And Loeb's Galileo project is specifically designing instruments to detect small, fast-moving objects that might be artificial. Within the next decade, we'll go from detecting one interstellar visitor every few years to potentially finding them weekly. That's when the real science begins, when we have enough data to determine what's normal, what's unusual, and what might be something else entirely. But there's one more twist to this story, something that might change how we think about 3I Atlas entirely. Remember at the beginning when I mentioned a chemical signature that has even skeptics questioning their assumptions? Here it is. 3I Atlas's nitrogen to carbon ratio matches a very specific environment, the kind found in the outer reaches of protoplanetary disks around young stars. But here's the problem. 3I Atlas could potentially be billions of years old, possibly even from the early beginnings of the universe, based on its trajectory through the galactic thick disk. It formed when the universe was much younger, when stellar chemistry was different. The nitrogen enrichment we're seeing shouldn't exist in an object that old, at least not according to our current models of stellar evolution and planetary formation. Some scientists are now proposing that 3I Atlas might have formed in a stellar environment we've never directly observed, perhaps around one of the first generation of stars after the Big Bang, or in a binary system with unusual elemental mixing. Others suggest it could have been chemically altered during its billions of years in interstellar space, though no known process would produce these specific changes. And yes, a small minority, including Loeb, point out that an artificial object designed for long-duration interstellar travel might use nitrogen-rich materials for radiation shielding or propulsion. We don't know. And that's the point. 3I Atlas is a reminder that the universe is far stranger and more diverse than our Earth-based experience suggests. Whether it's a natural comet from an ancient, exotic stellar environment, or something else entirely, it's expanding our understanding of what's possible. As more interstellar visitors are detected in the coming years, we'll build a database of compositions, velocities, and behaviors. Maybe 3I Atlas will fit neatly into a pattern, or maybe it will remain an outlier, a cosmic mystery that keeps us wondering. So what do you think? Is 3I Atlas a natural comet with exotic chemistry from a long-dead star system? Or could it be something more? Perhaps our first detection of technology from beyond our world? Drop your theory in the comments below. And if you want to follow the next interstellar visitor that passes through, because there will be more, hit that subscribe button and turn on notifications. The universe is full of mysteries, and we're only just beginning to find them. Thanks for watching, and remember, the truth is out there.